Hi everybody, this is Module 3, Part 2. We're still looking at rational expressions, and in this module, or this part of the video, we are going to look at adding and subtracting like rational expressions, and then also unlike rational expressions, so finding that common denominator. We're going to start off with adding like rational expressions. So when you're adding or subtracting, you could do either. Like rational expressions, it means they have the same denominator. And just like if you were to add fractions with the same denominator or subtract them, you only add or subtract your numerators and then simplify the fraction. So you always keep that denominator the same. So for our first one, we have 3y over 5x plus 12y over 5x. So again, my denominator is the same, so I'm going to keep the 5x on the bottom and add my numerators. So 3y plus 12y, they are like terms, I can add them. It gives me 15y. And then you want to see, can you do any simplifying here? And the 5 and the 15, I do realize that I can simplify that as a fraction. I know that 5 goes into 15 3 times, so it would become 3y over x. And that would be my final answer there. Now for b, again, we have a common denominator of 2x minus 10, so I'm going to leave that. And on the top, it's addition. I'm going to add my x squareds because they're like terms, so it becomes 2x squared. And I have negative 5 and negative 20, so minus 25. And then I do want to look to see, can I do any factoring or anything? On the top, I can't do any factoring. On the bottom, I could pull out a 2, but it's not going to help me simplify. So we're going to leave it in factored form. And this would be our final answer. There's no simplification we can do. So the two examples on this page are subtraction. And the one thing you want to remember is when we're subtracting, you're subtracting this whole expression here. So remember, put those parentheses around that expression. And you have to distribute that negative. So it's going to become 2x plus 3. When I distribute my negative 1 there, minus x, and then plus 2. And we'll keep our common denominator, so we have on the bottom x squared minus x minus 30. On the top, I do want to combine like terms, so 2x minus x will give me x. 3 plus 2 will give me plus 5. Now, on the bottom, let's see if we can factor it, because we might be able to simplify there. And so it's an easy trinomial. And I know because I have two minus signs, I'm going to have a minus and a plus. I need to get a negative 1. So I'm going to use for 30, to multiply to get 30, we would use 5 and 6. I need a negative 6 and a positive 5, because that'll give me a negative 1. And then when I look at this, this is very similar to what we just did when simplifying rational expressions. The x plus 5 expressions can both cancel. Remember that equals a 1, so I still have that 1 on the top. So my final answer here is 1 over x minus 6. All right, let's look at D. We have a common denominator of x minus 4, so I'm going to write that denominator, x squared minus 4, not x minus 4. I do have to distribute that negative sign there. So on the top right now, I have x squared plus 3x minus 7x, and then two negatives will make that plus a positive 4. So that is going to give me x squared minus 4x plus 4 on the top over x squared minus 4. And now I do want to see, can I factor? I know the bottom I can factor to x plus 2, x minus 2. So I'm going to factor that. The top is a perfect square trinomial. It's an easy trinomial. I know it's going to be x. I need a negative 4, and to get a positive 4, we're going to do negative 2. So x minus 2, x minus 2. And when I go to simplify here, I can take out one pair of x minus 2's. So my final answer is going to be x minus 2 over x plus 2. And I can't get rid of the x's because, again, they're part of a family. You don't want to bust up families. You can't rip them away. So it has to be the whole expression or nothing. So I can't do any simplifying. That is my final answer. All right, now the next thing we're going to look at is finding the least common denominator for rational expressions, because the first few we did were nice because they had a common denominator. But as you know in life, not everything is nice and easy like that. We don't always have a common denominator. So you always want to try to find the least common denominator. And your least common denominator, or LCD, of two or more rational expressions is going to be the highest power of each unique factor in any denominator. So remember, unique factors are different factors. You want to include all of the different factors in your least common denominator. And you do need to make sure your denominators are factored first before you find the LCD. So here for A, I have two monomials in my denominators. I have 2x cubed and 10x squared. So we have unique factors. We have 2 and 10, which are the numbers. So if I were to add two fractions together that had a denominator of 2 and 10, I think what's the smallest multiple of 2 and 10 that will work? And hopefully you said, well, you know, like for 2's, I know if I skip count by 2's, or I look at my multiples of 2, 2, 4, 6, 8, and then 10. Ooh, and I know 10 would be 10, 20, 30. So my LCD for 2 and 10 is going to be 10, because that's the least common denominator, or the least common multiple for those two. And then for my x's, I have x cubed and x squared. You want to choose the highest power of each unique factor. So we're going to go with x cubed. So that would be my LCD there for that problem. For B, again, look at your numbers first. What's my greatest common, or my least common denominator for 9 and 6? And again, think about your factors of 6, or not, your multiples of 6, excuse me. So like 6 times 1 is 6. 6 times 2 is 12. Those don't work with 9. 3 times 6 is 18. And now I do recognize that 9 also has a multiple of 18. So that's going to be my least common denominator. It's going to be 18, because for 9, again, it would be 9. And then 18, so that's their least common. They both have x's, so we definitely have to include an x. We have x squared or x. Remember, you want the highest power, so we're going to do x squared. Y squared and y, we're definitely going to choose the y squared. So this would be our LCD for B. All right, now for C. We do need to factor this denominator before we look for an LCD. So I know I can pull out a 2x. So we're going to have 2x times, let me fix that, times x plus 4. And then our other denominator still is our 4x. So we are looking at 2x times x plus 4 and 4x. Now, you need all of your unique factors. In this denominator right here, I have 3 unique factors. I have 2 times x plus 4. So in my LCD, I don't have x plus 4 in the other one. It's a unique factor. I know I'm going to need that, so I'm going to put it right there. So you're going to need that whole expression. Now for 2 and 4, they're both numbers. So what's my greatest common multiple or my least common multiple for those two? And hopefully you're saying, well, I know that, if we skip count by 2s, 2 goes to 4. So that's going to give me an LCD of 4. I'm going to move that x plus 4 over. All right, so we're going to have 4. We have our x plus 4 still. And then they both have an x, and they're both to the first power, so we're going to choose that x. So my LCD here, all my unique factors included. We had a single number, we had the single x, and we had the expression x plus 4. So they're all included here. And that would be my LCD for that one. Okay, so here for D, both denominators are already factored. We have 3x minus 4 and 4x plus 3, both factored. So really for this one, it looks kind of hard, but it's really rather simple because we have, for my LCD, we have 2 unique factors. We have 3x minus 4 and 4x plus 3. That's going to be my LCD because those are our 2 unique factors. They're in fully factored form. They're both different. So that would be my LCD there. You would just put the 2 together. Now for E, we can factor each denominator. So for the first one, I can pull out a 7. So it becomes 7 times x minus 2. And then for the other one, it would factor to x minus 2 times x minus 2, or we want to simplify it, x minus 2 squared. So now when we look at our factors, we have 7 times x minus 2 and x minus 2 squared. So here for my LCD, what I want to do is each unique factor we're going to put in our LCD, and we're always going to choose the highest power. So 7, it's all by itself. There's no other factor like it. We're going to use 7. X minus 2, I have one in this denominator and one in this one. But I want to choose the highest power. So my LCD is going to be 7 times x minus 2 squared. Make that into a black. There you go. So my LCD here is 7 times x minus 2 squared. All right, let's take a look at F. So my first denominator, my 2x squared minus 2, when I factor it, I can pull out a 2, so it becomes x squared minus 1. But that x squared minus 1, difference of perfect squares, I can factor that into 2 times x minus 1, x plus 1. Okay, so there's some unique factors. Now I have to look at the 8x, or the x squared plus 8x minus 9. So that can factor into x and x. I need it to multiply to get 9 and add to 8 with 2 different signs. So I'm going to have to use 9 and 1. I want a positive 8, so we're going to have a positive 9 and a negative, 1. All right, so now when I'm looking at my factors, I got to find my unique factors here. For the first one, I have a 2. I don't have that in anything else, so that's going to go in my LCD because you want all of your unique or different factors. Both both factored forms have x minus 1. They're both to the first power, so you don't put both in there. You choose, again, one of those. So we're going to do x minus 1. Okay, so I took care of that. And then I have x plus 1. It has no other factors like it, so I have to include it. And then x plus 9. So that gave us kind of a long least common denominator, but that would be it, because you want to put, if your factor is repeated, you only put it in the denominator once, and then each unique factor goes in. Well, if it's repeated in both, you put it in once. All right, so here they have given us a denominator, and they want us to rewrite our rational expression to have that equivalent or that given denominator. So it's kind of like writing our equivalent fractions here. So we're going from 7 over 2x to having a denominator of 8x cubed. So that's my new denominator, 8x cubed right there. And what I need to figure out here is, what did they multiply this 2x by to get 8x cubed? So to go from 2x to 8x cubed, I know to go, that's not cubed, to go from 2 to 8, I have to multiply by 4. So I know that I'm going to multiply, I multiplied here by 4. And then to go from x to x cubed, I needed another x squared in there. So if I multiply the bottom by 4x squared, I have to do the same thing to the top. So 7 times 4 is 28, and then x squared. So my equivalent fraction here is 28x squared over 8x cubed. And again, whatever you multiply the bottom by, you have to multiply the top by. So when we look at B, there is one error in our math here, or our paper. That should be a y right there. So we should have 20x squared y cubed. My denominator currently is 5xy. So to go from 5 to 20, I know I multiplied by a 4. To go from x to x squared, I have one x here, and I added another one, so I used another x. To go from y to y cubed, I need 2 more, so y squared. So if I multiply the bottom by 4x y squared to get this 20x squared y cubed, I do the same thing to the top. So I'm going to multiply this top by 4xy squared. And it's going to give me on the top 4 times 2 is 8. And then we'll have xy squared. So it's going to give me 8xy squared over 20x squared y cubed. So it's really figuring out what did you multiply the bottom by to get that denominator. Do the same thing to the top. Now, for C, it's nice they gave us this x squared minus 6x plus 8, but it's not in factored form. We really need it in factored form to help us out. So let's factor that first. And it would factor to x minus 2, x minus 4. So if we look at our starting denominator, we had x minus 2. We went from that to x minus 2 times x minus 4. So that means they multiplied the top and the bottom of the second expression by x minus 4. So we are going to multiply. On the top, we'll have 7x times x minus 4. And we can multiply it out, or we can leave it like that. Typically, we will need to distribute to help us add our expressions together. So we'll go ahead and distribute it and see what it turns into. So it would be 7x squared minus 28x over, and then we know when we FOIL this, we get x squared minus 6x plus 8. Okay. Now for D, we do want to go ahead and factor this denominator first so we can see what we're working with, what factors we have. I'm going to write it over here. So we have 6x squared plus 18x minus 60. I do know that I can pull out a 6. So I have a 6, and that's going to make it x squared plus 3x minus 20. And then we can factor that inside to let's see here, x plus 5x, no, I want 5 and 4 because I need to get 3. So let me erase that. So we need to make it 20. And it has to add to 3. So we have 20, we have 1 and 20, 2 and 10, 5 and 4. But none of those will add to a positive 3. So I believe I'm going to say they might have an error in this problem. I don't think that it is listed correctly. Oh, because you know why? I did it wrong. I factored wrong. Let's redo here. And again, this is where you're going to see your teacher is definitely not perfect. I pulled out a 6. So that makes x squared plus 3x minus 10. All right, which then will factor to x plus 5, x minus 2. And now this 3x minus 6, we can factor a 3 out of that, so it becomes x minus 2. So if we compare this GC, or this denominator, to this one, I know to get from 3 to 6, I need to multiply by a 2. And I have the x minus 2, but I'm missing the x plus 5. So that's what I multiply this denominator by to get this one. So I'm going to do that same thing to the top. I'm going to do 7 times 2 times x plus 5. We will distribute here. So 7 times 2 is 14. We have 14 times x plus 5, which is going to give me 14x plus 14 times 5 is, I think it is 70. Yep. All right. Sorry for that mistake there. I know that made it a little confusing. But it's kind of good to see mistakes sometimes, because your brain grows a little bit when you make mistakes. And you can see your teacher is definitely not perfect. Definitely not today. So now we're going to take all that we've done practicing finding a common denominator and creating equivalent rational expressions to now add or subtract unlike rational expressions. So again, in order to do this, we have to find a common denominator. And then we have to rewrite that fraction using the common denominator, add or subtract our numerators, and then simplify if needed. So for our first one, we have 3 over 10x plus 5 over 4x squared. My LCD here, for 10 and 4, my lowest common multiple for those two would be 40 is 1, but it's not the lowest. We could actually do 20, because that is a multiple of 10 and of 4. And then they both have x, but we want to choose the highest power, so we're going to choose our x squared. So now when we're writing equivalent fractions, I kind of like to do this. I like to look at my 3 over 10x, just like in the other slide where we had it equal to that denominator. So I know to go from 10x to 20x squared, I need to multiply by 2x. So that means I'm going to multiply the 3 by 2x, because whatever I do to the bottom, I do to the top. And it's going to give me a 6x on top, because 3 times 2 is 6. And then my 4, or my 5 over 4x squared to get it to 20x squared. I know I have the x squared, so that's fine. I just need to multiply this 4 times 5 to make it 20. So I'll multiply the top times 5, and I get 25. So my problem with equivalent or a common denominator will be 6x over 20x squared plus 25 over 20x squared. Now, our numerators are not like terms, so I really can't add them together. But what I can do is write it as one single fraction. So I can have 6x plus 25 over 20x squared. And that would be my final answer there. I can't do any more because there's no simplifying I can do. All right, let's look at B. For 8 and 6, my common denominator here, if I think about my multiples of 8, we have 8, we have 16, we have 24. And if I look at those, I know 8 and 16 don't work with 6, but I do know 24 does. So for my LCD, I'm going to use 24. And then I need each unique variable. So I have an x in the first one. I have to include that in my LCD. And then I also have a y in the second. So that's going to be included. So my LCD here is 24xy. So again, if we look at it, trying to make those equivalent fractions, we have 7y over 8x. And I want to turn that into a denominator of 24xy. So I am missing from the 8x to get it to 24, I need to multiply times 3, and I need a y. So I'm going to multiply the top by 3y. So that is going to give me on the top 7 times 3 is 21. Y times y is y squared. So let me see here. We have 21 y squared over 24xy minus, all right, now my 7x over 6y. To get that to 24xy, I need to multiply the 6 times a 4 and an x. So I'll multiply the top by 4x. And that's going to give me 28x squared. So that new problem is minus 28x squared over 24xy. And now that I have my common denominator, I can go ahead and do my subtracting here. They're not like terms, so it's going to turn into just being a single fraction again. 21y squared minus 28x squared over 24xy. Now you do want to see if you can simplify. There is a greatest common factor on the top of 7. But 7 and 24 have no common factors, so I really can't do any simplifying. So it doesn't really make any sense to pull it out. So this would be my final answer there. Okay, for C, we have, again, our two unique denominators here. We have 3x minus 2, which I can't factor anymore, and 4x plus 1. So my LCD here is just going to be the 3x minus 2 times 4x plus 1. We're just going to put those factors together. So it's an addition problem, so that means that we are going to, if I take my 4 over 3x minus 2, in order to get it to my denominator of 3x minus 2 over 4x plus 1, I need to multiply both the top and the bottom by 4x plus 1. All right, so that's going to give me on the top 4 times 4x plus 1. Or if we distribute, I'm going to write the actual problem kind of down here. We're going to end up with 16x plus 4 plus, and I'm going to put that one big denominator there, 3x minus 2 over 4x plus 1. Okay, and I am going to erase the work here so I can put the other fraction in so we have space. So if you want to pause the video, write it down. All right, let's erase this part. So my other fraction that I need to take to my common denominator is 5 over 4x plus 1. And again, I want to make it have that denominator of 3x minus 2 times 4x plus 1. So that means that I need to multiply the top and the bottom by 3x minus 2. And that will give me 5 times 3x minus 2, or 15x minus 10 when we distribute. And we have that common denominator, so I just went ahead and wrote it on the bottom because I know I'm going to add the numerators together. Excuse me, when I add them together, 16x and 15x will give me 31x. And 4 minus 10 will give me a negative 6, all over 3x minus 2 and 4x plus 1. And I don't see any common denominators here, or common factors that I can pull out of the top. So this would be my final answer. There's really no simplification that I can do. All right, now if we look at D, again, it's going to be very similar to C because my common denominator here is going to be 3x plus 8 times 5x minus 3 because I can't do any factoring of either. So my LCD is 3x plus 8 times 5x minus 3. So now we do have subtraction here, so we have to be mindful of that. And what I kind of do is when I have subtraction and I know I'm going to be distributing, I do this. I make this plus, so I make an addition of the opposite. So now I know to distribute that negative with the 2. So my first fraction is x over 3x plus 8. And I need to have a denominator of 3x plus 8 times 5x minus 3. So I am missing my 5x minus 3. So I'm going to multiply the bottom and the top by 5x minus 3. So on the top, it is going to give me, when I distribute, 5x squared minus 3x. So again, I'm going to put that down here, 5x squared minus 3x, all over. I'm going to just go ahead and combine my denominators down here at the bottom. All right, now, I'm going to go ahead and erase, so pause the video if you need to. Okay, next, we need our LCD for, we have negative 2 over 5x minus 3. And I have to have this LCD 3x plus 8, 5x minus 3. So for this one, I am missing 3x plus 8. So I'm going to multiply the top and the bottom by 3x plus 8. So when I distribute, it's going to give me negative 6x minus 16. Again, I distribute that negative 2, so minus 6x minus 16. So let's go ahead and simplify this. And it's going to give me 5x squared minus 9x minus 16 over 3x plus 8 and 5x minus 3. Now we can look at the 5x squared minus 9x minus 16 and see if it is factorable. It is factorable, but when we factor it, we get 5x minus 16 and x plus 1, which are neither of these two factors here, so we can't simplify, so we can leave it just in this format. Okay, so now for E, we have one denominator of x minus 6, and then we have a whole number 3, which remember that whole number 3 is like 3 over 1. So we do have to, in order to add these, have the same denominator. The nice thing here is my LCD is just going to be x minus 6, because that is my only denominator other than the 1. So my 5 over x minus 6 is already, it's the 3 over 1 that I have to make have a denominator of x over 6. So if I write it down here, I have 3 over 1, and I need it to have a denominator of x minus 6. So that means that I had to multiply the bottom times x minus 6, which means I'll multiply that top times x minus 6. Or if I distribute, it becomes 3x minus 18. And now I'm going to go ahead and erase that so we can combine our like terms. So we have x minus 6 on the bottom. It will be 3x, and then 5 plus negative 18 is going to give me negative 13. And I don't see any simplifying that I can do, so that one is simplified as much as possible. Let's take a look at F. We got to factor our denominator there, our x squared plus 6x plus 9. So when we factor this denominator, if I have x squared plus 6x plus 9, if you recall, that will factor to x plus 3 times x plus 3, or when we simplify it, x plus 3 squared. So my LCD here, I have x plus 3 in this denominator and x plus 3 squared here. The denominators, the factors are the same, the powers are different. So my LCD is going to be x plus 3 squared. Which is kind of nice because this second fraction right here, it's already in that has that denominator already. So it is the 2 over x plus 3 that we have to turn into x plus 3 squared. So that means I'm going to have to multiply this bottom times x plus 3 and the top times x plus 3. So it's going to give me 2x plus 6 over x plus 3 squared minus 7x over x plus 3 squared. So when I do the math here, 2x minus 7x will give me negative 5x plus 6 over x plus 3 squared. And I can't do any simplifying, so that one is also done. Okay, so now for G, we have two denominators that need to be simplified here to find the LCD. Again, it's subtraction, so that first thing I want to do, so I don't forget to distribute that negative, is make that plus a negative 4x. So do addition of the opposite. Now, for my first denominator, when I factor x squared minus 25, hopefully you're like, oh, that is x plus 5 times x minus 5. So you see that difference of perfect squares right away because we've been factoring so much. Now, for the other denominator, it is going to be, we need to use a positive and a negative. And you know what they did when they wrote this problem? They made an error here. So on your paper, I want you to fix this. Make this a negative 6x and a positive 5 right there, because otherwise it will not factor, and we want it to factor. So make that x squared minus 6x plus 5. So now when we go to factor it, it'll be two negative signs, and it will be x minus 5 times x minus 1. So now we need all of our unique factors in our LCD. So x plus 5 is in one of them. I need x plus 5. Now x minus 5 is in both, but remember I choose the highest power. Since they have the same power, we're just going to choose x minus 5. So we got rid of those unique factors. And then our last one is x minus 1. So this one, we have 3 common factors or 3 factors in our LCD. It's going to be kind of a pain, but it's not going to be horrible. All right, so my 2 over x minus 5, x plus 5. In order to have an LCD of x plus 5, x minus 5, and x minus 1, we need to multiply the top and the bottom by x minus 1. So that's going to give me on the top 2x minus 2 when I distribute. And then our other one, we have negative 4x over, when it's factored, the correct trinomial, x minus 5 times x minus 1. And I need it to be x plus 5 times x minus 5 times x minus 1. So I am missing x plus 5 here. So when I distribute, that will give me negative 4x squared minus 20x. Okay, so right now we have this, and I'm going to write it out with one denominator because we're running out of room. So it is x plus 5, x minus 5, x minus 1, and we have 2x minus 2 minus 4x squared minus 20x. And we do need to simplify this. So I'm going to put it in descending order. We're going to have negative 4x squared minus 2x and negative 20x will give me negative 18x minus 2 all over x plus 5, x minus 5, x minus 1. And while I can pull a negative 2 out of my top trinomial, it's not going to help me factor or get anything to simplify on the bottom. So we're going to leave it like this as our final answer. All right, we are going to look at our last one, H, for this module, for Module 3. It's our last problem for our notes. And we are going to start off by factoring those denominators because they are not factored, so we got to factor them to find our LCD. X squared plus 12x plus 20 is going to factor to 20. I can multiply 2 and 10, and that will add to 12. So it's going to be x plus 2 times x plus 10. And then on the other one, it's going to factor, so I needed 8 this time, different signs. So 2 and 10 again, but this time it's going to be x plus 10, x minus 2, because that will give me 20, but also add to positive 8. So now when I'm finding my LCD, all right, I need to look at my unique factors. Both problems have an x plus 10, so I know I'm going to use that. This is another unique factor of x plus 2. We don't want to leave anything out. And then x minus 2. So again, we have those 3 factors in our LCD. So when we go to write our equivalent fractions, right now I have x over x plus 2 times x plus 10 but I needed to have that denominator of x plus 10 times x plus 2 times x minus 2. So I am missing an x minus 2. So when I distribute, that's going to give me x squared minus 2x. And then my second fraction, I have 3 over the factored form of x plus 10 times x minus 2. But again, I needed to have a denominator of x plus 10 times x plus 2 times x minus 2. So I am missing this time x plus 2. So I'm going to multiply by x plus 2. So that's going to give me 3x plus 6. And it is an addition problem, so I'm going to add these two numerators together and make it into that one single fraction. So my denominator is going to be x plus 10 times x plus 2 times x minus 2. When I combine like terms, I'm going to have x squared, negative 2x, and positive 3x will give me positive x, so plus x, and then plus 6. And it looks like when I go to simplify, there's nothing I can do to simplify this. So this will be our final answer to our final problem for this module. I hope you've enjoyed this. Have a great day. Bye.